So hello everyone, welcome to the channel. So in this video I'm gonna show you mapping and analyzing the canopy height using the Global CHM dataset in Google Earth Engine, a case study of specific region in Meghalaya, India. So now let's get started. So now let me explain about what is a canopy height. A canopy height refers to the height of the trees, buildings and other structures above the ground topography. It is a measurement used in various applications including forestry, ecology and environmental studies. So what is an average tree canopy height? So average tree canopy height is an average height found by inventorying the height of the above ground level of all trees over the specified height within a specified radius. This measurement is used to track the vegetation and trees in the forest over time and calculate the biomass and estimate the leaf area index. So what is a forest canopy height? So the forest canopy height is the height of the highest vegetation component above the ground level. It is essential in normalizing the micrometeorological parameters and estimating the forest biomass and carbon pool. There are also different definitions of the forest canopy height, including the representative height of the taller trees composing the crown surface or the upper canopy layer, estimated on the basis of the cumulative basal area from the shortest tree plotted against the corresponding individual tree height. So what is a canopy height model? So canopy height models are created by subtracting the digital terrain model from the digital surface model, and the canopy height model shows the height or the residual distance between the ground and the top objects above the ground, including the actual height of the trees, buildings and other structures on the earth's surface. So now let me show you the dataset we're going to use for this particular video. So this is a dataset of high resolution 1 meter global canopy height map. So this particular dataset is available in Awesome GE community catalog. So the global canopy height map dataset offers a comprehensive insight into tree canopy height worldwide and providing an overview of tree canopy presence and height for the analyzed period between 2009 to 2020, with 80% of the dataset is obtained from imagery acquired between 2018 and 2020. So this particular dataset can be accessed through this code here. So using this code, we're gonna use this dataset, that is a high resolution canopy dataset of 1 meter. So using this code, we can able to access this dataset. So let me get back to Earth Engine. So we can able to visualize this particular image. We have classified the different canopy heights based on using this global CHM dataset. So let me show you this. So you can go through about the canopy height and canopy height model. So first we're gonna select a study area of our choice. So to select the study area of our choice, we're gonna use this HydroBASIN of level 6 dataset. So to load our HydroBASIN level 6 dataset, we define a variable called watershed equals to feature collection WWF hydroshed version 1 basin high base 6. So to add this layer, that is global HydroBASIN layer, we define map.add layer watershed with the default visualization parameter and output the layer name as watershed. So next, to select a particular, that is to select your study area of your choice from this HydroBASIN global dataset. So you can choose any location of your choice. So you can able to see here, let me turn this off. So you can select any watershed of your choice. So to do that, we're going to use this option called add a marker. So now I'm going to select this particular area. So I'm going to place it my marker here. So now you can able to see I have placed my marker here. So let me go to the this section here. We have defined a variable called geometry point with the latitude and longitude. So now I'm going to paste my latitude and longitude in this particular variable called coordinates. So for that, I'm going to click this option called show the generated codes. So now I'm going to copy my latitude and longitude. I'm going to paste it in that variable called variable coordinates. So I have copied this coordinates here. Let me close this and I'm going to paste it here. Control V to paste it, and similarly I'm going to copy the other coordinates. So I'm going to copy this. So I'm going to paste it here. So now we have defined our region of interest using this point that is a marker. So you can able to see that the red here, the green color which indicates the marker. Using those coordinates, we have placed those coordinates here to create a region of interest of our choice. So for that, we defined a variable coordinates with the latitude and longitude. We define another variable point of interest, that is our study area, equals to geometry.point coordinates, referring to our coordinates. And next, to select this particular basin of your choice, we defined another variable. So to filter a basin collection to get a specific ROI containing the point. So for that, to filter this particular basin, we define this variable called region of interest equals to watershed.filterBound point of interest. So the point of interest refers to this particular variable. And next, to add our region of interest, that is our study area, we define map.centerObject region of interest, and to add those layer, we define map.addLayer region of interest with the default visualization parameter and output the layer name as study area. So let me show you that here. So I'm gonna navigate to the layer section here and click this option called study area. So now here you can able to visualize we have managed to create our study area, that is using our hydroshed basins. We have just created a region of our choice. This particular, we have managed to create a watershed of our choice here, selected it. And next we're going to perform our canopy mapping and analyzing using this particular study area. So basically this set of codes here that defines the point of interest and filters the basin collection to get the specific ROI containing this point, that is this particular point here. So the ROI is then centered and we have added those layer. So next we're going to load our the canopy height data. So for that, we define this variable called canopy height collection equals to w.image collection project meta forest monitoring OKW37 asset canopy height. So now to mosaic this particular image, the entire image of the global canopy height image collection, so we are using this specific function, that is .mosaic function. So to mosaic the entire images for this canopy height image collection, that is Global CHM dataset. And now to view the property of this particular image, we define print canopy height collection and output the layer name as canopy height collection properties. So you can able to see that. Let me show you that. So this is the canopy height collection properties. So here you can able to visualize we have this band called in this particular dataset of Global CHM dataset, it has a band called cover code, which is an unsigned int 8 and with the coordinate reference system is given here EPSG 4326. So now next we're going to define a visualization parameter for our canopy height dataset. So for that we define this variable called visparams1 equals to, we define the opacity equals to 1. So it controls the transparency of the image. So an opacity of 1 means that image is fully opaque. And next we define the bands here. So we are using this cover code. We have defined cover code 3 times. So cover code band 4 is used for the green, that is red, green and blue channel. So it results in a grayscale visualization. So the gamma value of 1 here represents no adjustment to the brightness and the contrast of this image, that is our canopy height image. And similarly we have defined another visualization parameter here, visparams2, setting an opacity of 1, and bands we have defined similarly the covered code, so the red, blue and green channel in grayscale, and we set a minimum and maximum value. So set a minimum value for the data scaling and similarly the maximum value for our data scaling, and the gamma value of 1 here represents a no adjustment to the brightness and contrast of the image. So next, to add this canopy height image into Google Earth Engine, we define map.addLayer canopy height collection. So this particular refers to this dataset, that is our global canopy height image, global canopy height, the model dataset here, and you can able to see that we are adding that particular dataset. So we have defined map.addLayer canopy height collection dot clip. So clip refers to the region of interest, that is our this particular area, the region of interest, this particular study area. So for that we defined dot clip region of interest, and the visualization parameter, we are for visualization purposes we are using this particular variable here, and output the layer name as canopy height, and false here, which is indicate to turn off the layer, turn off the layer. So we are using this particular false. So now let me show you the canopy height here. So we're gonna navigate to this option here, and I'm gonna select this in the layer section. I'm gonna select canopy height. So let me zoom in. So let me turn on the watershed here. So this is our canopy height model dataset. You can able to visualize it. So here in this image we have a different grayscale color here. So the black areas here indicates the water bodies and lake areas. So let me zoom into the study area. So you can able to visualize this is a Brahmaputra river which is running in the middle of this study area here. The black portion which indicates the lakes and the water bodies. And from this image you can able to visualize this particular study area is covered by a lot of water bodies here. Let me turn off this to satellite mode here, and let me turn off this layer, or I can adjust this transparency level. So you can able to see here, this is the lake, that is a river channel here. You can able to see that, and let me increase the transparency. So you can able to see that in the middle portion of the study area we have this Brahmaputra river. And similarly, let me navigate to in this part of the section here, and you can able to see in the white areas here. So the white areas here indicates the vegetation areas. You can able to see that. Let me reduce the transparency here. So you can able to see that all the vegetation areas are clearly highlighted in white color, and the non-vegetated areas are indicated in black color. You can able to see that clearly here. So let me show you the definition of this canopy height once more. So the canopy height refers to the height of the trees above the ground topography. So this is the definition. The canopy height refers to the height of the trees above the ground topography. So here you can able to see that all the trees being clearly highlighted in the white color. So this is a very good spatial resolution dataset. It has a 1 meter of resolution. And similarly, let me navigate to the other part of these areas. Let me navigate to here in this section here. You can able to see here in the satellite image. It is so it is very dense forest here. You can able to see that. So this particular dataset is it's able to capture all those here. So the white areas which indicates the canopy areas. And also this particular dataset has you can able to see here. So it is able to classify all the water and non-water areas. Let me show you here. So it can classify all the water and non-water areas. So you can able to see from this image here. So all the rivers and the water and non-water areas are clearly highlighted in this image. Let me zoom in here. So you can able to see here. This is a very high resolution image. So let me again show you this. So it can able to clearly highlight all the water and non-water areas and also the forest areas. You can able to see here. So this portion indicates it is a very dense forest. It is clearly highlighted in this data set here. Let me zoom in more here. So you can able to see these are forest areas. So you can able to see that. So it clearly highlights all the trees in these areas here. So it is a very good data here. It has a very good accuracy. You can able to see here. So when I change the transparency, you can clearly able to see all the trees are clearly highlighted here in this data set. And similarly, and now let me zoom into this farm area here in this location here. You can able to see that. So let me turn on my canopy height dataset. So you can able to see that this particular dataset clearly differentiates between the cropland as well as the forest areas. So the cropland versus trees can be clearly distinguished using this particular dataset. Now let me zoom into this areas here. So you can able to see these are the crop areas for the specific study region. So let me turn on this dataset here. So which can clearly differentiates between a cropland separate a cropland from the forest areas using this particular data is very good in separating forest land from croplands. And this particular data is very good for the remote sensing data analysis. And this particular data set is incredibly very helpful for forest studies. So this particular data set, this set of line of codes here is used to load the canopy height image collection and creates a mosaic, and we define the visualization parameter, and the canopy height image is flipped using our the study area here. So you can able to see we have used our region of interest, and we have added the image into our earth engine. So next I could like to measure the size of the height of these canopies. You can able to see here. So I could like to measure the size of this height of these canopies. So now to visualize the canopy height here, so we're gonna navigate to this option here. So you're gonna click this option called inspector, and you can able to see here. So I'm gonna mark this part of this area, and we're gonna visualize the height of this canopy. So I'm gonna click here. So here you can able to visualize the height of this particular canopy. We have clicked here. It is around 23 meters. And similarly, I'm gonna click this particular area here. Let me zoom in, and I'm gonna click this canopy here. Let us visualize the height here. So which is 15 meters. And I'm gonna click in the gray areas here, and we're gonna see the height here. It is around 0 meters. So let me click here. So the height of this canopy is around 11 meters. And also the brighter region has a higher canopy height compared to the gray areas here, which indicates of lower canopy height is around 0 meters. So the white areas here has a higher canopy height, which is indicated in this area is around 14 meters. Let me click here. So it is around 12 meters. So here I'm gonna check the height of the canopy using the inspector tool. So it is around 15 meters, and similarly in this area it is around 15 meters. In the gray areas, so it is around 0 meters. So the darker region here basically shows a lower canopy height compared to the brighter areas has a higher canopy heights. So suppose if you want to visualize the range of this canopy height for this particular study area, so for that we're going to use the histogram. So to create a histogram for this canopy height, that is to see the range of the canopy height for this region with their frequency. So for that we defined a print UI chart image.histogram, the canopy height collection referring to our canopy dataset, and region of interest referring to our study area. So the histogram is helping you to see the range of different heights of the canopy for the specific study area. So for the specific study area, that is we have managed to create using the HydroShed dataset. So the canopy height is the histogram will help us to visualize the plot range of the canopy heights. So we're gonna use this histogram. So we set a spatial resolution of 100 here. So let me navigate to this option console section here. So in the graph here you can able to see that this is the histogram of cover code, that is our the Global Canopy Height Model dataset. So we are specifically referring to that band here that is called cover code. So from this histogram you can able to see this is the height of the canopy height here, which is ranges from 0 to 30 meters. So from this graph here you can able to visualize that each of this the canopy height has a different frequency here. You can able to observe. So each of this different canopy height has a different level of frequencies here. So in this here, the 0 meter canopy height, which has the highest level of frequency, which is close to around 600,000. So the canopy height of around 2 meters, which has a frequency that is close to 200,000. And here the canopy height of 4 meters, which has a frequency of around maybe around 180,000 frequency. So the height of the canopy is ranging from 0 to 30 meters. So now you can see, for example, a very low percent of canopies. So the low percent of canopy height is above 20 meters here. So after that is very low compared to the 20 meters canopy. So from the according to this this histogram here, the most of the trees and the most of the forest covers are in this region, or the most of the pixels showing the canopy height is around 0 here. You can able to see here the pixel percent here, and also here the 0 pixel may be showing the pixels related to the non-forest region, such as lake or agricultural land, or the urban areas, or the build-up areas, which is indicated in the 0 meter canopy height. And the greater values only showing the actual forest or the tree areas greater than 0, which is greater than 0, or the areas which is forest or the tree cover in the region, which is indicated greater than canopy height of 0, which indicates or the forest area or the tree cover for this region. So the next step is we're going to remove all the non-forest areas from this data set here. So you can able to see that the 0 meter, that is 0 canopy height, indicates the non-forest area or the urban areas. So we're going to remove this non-forest or the non-forest areas from this data set. So next step, we're going to create a mask for the forest area with the canopy height greater than 0. So we're going to create a forest mask and visualize only the forest areas. So for that, we're going to define a variable called forest mask equals to the canopy height dot greater than 0. So next we defined a variable called forest area equals to canopy height collection dot update mask forest mask, refers to this particular variable here. So this particular set of code will remove all the non-forest areas from the canopy dataset. So to visualize only the forest area, we're going to add this layer, that is map.add layer forest area dot clip region of interest. So the region of interest refers to our study area. We set with the default visualization parameter and output the layer name as forest area. So now we're going to navigate to the layer section here. Let me turn off the canopy height dataset, and I'm going to turn on the forest area dataset here. Let me turn off the study area. So now you can able to visualize here. So from this image you can able to visualize we have managed to remove all the non-forest pixels. Let me turn to this satellite mode here, the map mode. So all this the gray area here indicates the forest areas. We have managed to remove all the non-forest areas. So now this black gray areas indicates the forest areas for this study region. So now we have managed to remove all the non-forest areas. So now let us create a histogram for this forest areas. So we have managed to remove all non-forest areas. Now let us create a histogram for this forest area. So for that we define print UI chart.image.histogram forest area, referring to this particular variable called forest areas. And region of interest refers to a study area, this particular study area. And we set a spatial resolution of around 100. So now we're going to visualize it here in the second graph here. So now in the second graph you can able to visualize all the 0, that is the non-forest areas are removed. So now the canopy height starts from 1 meter to 29 meters. Previously the canopy height dataset has shown us from 0 meters to 30 meters. So we have managed to remove all the 0 canopy height pixels from our canopy dataset, and this is the current dataset. Now the canopy height varies from 1 meter to 29 meters. You can able to view from this histogram too. So you can compare both the histograms here. This is our forest area histogram. This is the canopy height datasets histogram. So we managed to remove all the 0 canopy height. So you can able to see the frequency here, and this is the previous frequencies. So now the canopy heights ranging from 1 to 29 meters. So next we're gonna find our mean canopy height and maximum canopy height and minimum canopy height. So for that we define this particular variable called mean canopy height equals to forest area dot reduced region. So we are using reducer, reducer.mean function to calculate the mean canopy height, and the geometry here refers to a region of interest, that is our study area, and the spatial resolution of around 100. And we set the values. So in order to return the mean canopy height value, we define dot value dot get 0. So now to visualize our maximum canopy height, we define print max canopy height and output the name as a max canopy height. So referring to this variable called max canopy height here, and output the layer name as max canopy height. So next, to calculate the minimum canopy height, we are using a similar set of codes here. Similarly, we define a variable minimum canopy height, forest area dot reduce region, reducer referring to mean, geometry, the study area, scale spatial resolution, and return as the minimum dot get the first function, get the first item, and print as a minimum canopy height and referring to this particular variable. So which gives us a minimum canopy height. And similarly, the maximum canopy height also being can be done using set this variable maximum canopy height, similar set of code, reducer referring to max, and geometry is study area, spatial resolution, and output as a maximum canopy height, referring to this particular variable here, the max canopy height. So this set of variable will calculate the mean, mean, and maximum and minimum canopy height. So which can be found here. So the mean canopy height is around 7.3 meters, and the maximum canopy height is around 30 meters, and the minimum canopy height is around 1 meters. So here we have found the maximum canopy height to be around 30, but from the graph here, so you can able to visualize in the graph here. So let me show you here. So in this graph here, the 30-meter canopy, we can't able to find the 30-meter canopy. So to get a more realistic maximum height of the canopy, so we're gonna use this percentile canopy height to get the exact canopy height for this region, maximum canopy height for this region. So for that, we're gonna use this percentile to get more realistic maximum height of this canopy in this study area. So the other way to get the maximum the canopy height value with high frequency is using the percentile. So we're gonna use a similar set of code. First, we're gonna define variable canopy height 99 percentile equals to the forest area dot reduce region. So reducer, instead of max, we're gonna use this as a percentile 99. So AA dot reducer dot percentile 99. So the geometry is we're gonna refer as the region of interest, that is our study area, and the spatial resolution is around 100, and we get a return value as a first item. So to view the percentile canopy height, that is maximum height, we define the output as a percentile canopy height, and the referring to this particular variable called canopy height 99 percentile. So now we can able to visualize here the maximum canopy height in percentile. It is using percentile, we get around the maximum canopy height to be around 23 meters. So now we have managed to extract the mean, minimum, and maximum canopy value from the dataset for the specific study area. So next, so in the next step, we're gonna classify our canopy height into different classes. For example, in class 1, we're gonna classify the canopy height from 0 to 5 meters, and in the class 2, we're gonna classify as from 5 to 10 meters, and class 3, 10 to 20 meters, and class 4, greater than 20 meters. So to do that, we're gonna now create this variable. So we're gonna create a constant image with the value 0 for canopy height classification. So this is basically a manual classification by using the thresholding technique. So we're gonna use the different threshold values. For example, 0 to 5 meters, the first threshold, and 5 to 10 meters as a second class, and 10 to 20 meters is a third class, and greater than 20 meters is going to be the fourth class. So first we have to define create a constant raster. So for that, we define a variable called base image equals to $image.constant. So 0 here, and basically we are creating a constant image with including 0 values for all pixels. So using this constant image, then different classes could be identified through this different classes here, class 1 to class 4. So now we're going to classify our forest area into 4 classes based on the canopy height. So for that, first we're going to define a variable class 1 equals to base image dot var the forest area less than 5 meters, and we are giving it as a first class as a 1. The class 1 is which is indicated as 1 here. And to add this layer, we define map.addLayer class 1 dot clip the region of interest, that is our study area, and with the default visualization parameter, and output the layer name as canopy height from 0 to 5 meters. So the class 1 which indicating the canopy height ranging from 0 to 5 meters. So now let me show you that layer here. So navigate to the layer section. Let me turn off this. The canopy height from 0 to 5 meters. So this is the canopy height that is from 0 to 5 meters. You can able to see that here in this image. And similarly, let me show you another image. This is the canopy height from 5 to 10 meters. So you can able to see the difference in it. So this is 0 to 5 meters, and this is 5 to 10 meters, and this is 10 to 20 meters, and this is greater than 20 meters. You can see the different classification. So let me show you this. So for the class 2, we defined a variable called class 2 equals to class 1, where the forest area is greater than 5 and the forest area is less than 10. So which is represented as a 2 as a class 2. So next we define map.addLayer class 2 dot to clip region of interest default visualization parameter canopy height from 5 to 10 meters. And similarly, we defined a variable class 3 class 2 dot where the forest area greater than 10 and the forest area lesser than 20, and give it as a class 3. And to add this layer, map.addLayer class 3 dot clip region of interest default visualization parameter canopy height from 10 to 20 meters. And last, the class 4, the class 3 class 4 variable called class 4 is equals to class 3 where the forest area greater than 20, and we are giving as a class 4. And map.addLayer class 4 dot clip region of interest the canopy height that is greater than 20 meters. And at last, to add the classified the canopy height image to the map with different color palettes indicating the different classes from class 1 to class 4 in different colors, we defined this particular code map.addLayer class 4 dot clip region of interest. We are setting with a minimum value of 4 and to a maximum value of a minimum of 0 and a maximum of 4 here. So the 4 classes, that is class 1, 2, 3 and 4. So we have set a maximum to 4, and the color palette starting from black here indicates all the non-forest areas, and red here indicates the class 1, class 2, class 3 and class 4. So to return this image, we define classified canopy height. So it creates a constant image and classify the forest areas into 4 classes based on canopy height, and the classified image is then visualized in the map. So now to visualize it, let me show you that here. Let me turn this classified canopy height. So now you can able to visualize the classified canopy height here. So the black here indicates all the non-forest areas, and the class 2 indicates the classified canopy height class 1, that is 0 to 5 meters. You can able to see here from 0 to 5 meters. The class 2 which is from 5 to 10 meters, and class 3 is from 20 to 20, and class 4 is from greater than 20, which is indicated in different color: red, orange, green and blue. So this classified image, you can able to see that the classified canopy height image, this is the blues areas where the canopy height that is greater than 20 meters, and the red are the areas where the canopy height between from 0 to that is from greater than 0 to 5 meters, all the red areas. And similarly, the class 2 that indicates the 5 to 10 meters, which is indicated in this set of color here, that is in orange, and class 3 which is indicated in green color, and class 4 which is indicated in blue color. So now to export this image to a Google Drive, we define export.image.drive image class 4.clip region of interest. Description is canopy height classified, and the spatial resolution is around 30 meters. So region, that is our study area, region of interest dot geometry dot bound. So the maximum pixel value we set to 1 is to 10 power 30, and this is the coordinate reference system class 4 dot projection. So .crs coordinate reference system. So we're gonna export to the folder to a Google Drive called test. So basically this set of code exports a classified canopy height image to a Google Drive with a specified parameters. So now let us run this code. We're going to click this option called run. So you can able to visualize this image here, the classified canopy height. This is the output. So now you can able to, let me zoom in. You can be able to see the different classes of the canopy heights here. So now let us take a look at the application of this particular data set here. So using the application of this code here. So the forest management and conservation. So identifies an area with different canopy height from height classes to inform the conservation efforts and sustainable forest management practices. Monitor changes in canopy height over time to detect the deforestation, degradation and regrowth. Biodiversity studies use the canopy height data as a proxy for habitat complexity, which is critical for biodiversity assessment, and correlate the canopy height with the species diversity and distribution to inform wildlife management and protection strategies. Carbon stock estimation. Estimate the biomass and carbon stock in the forest by integrating the canopy height data with other forest inventory parameters. And support the climate change mitigation strategy by assessing the carbon sequestration potential of the forest. Land use planning and the disaster management. Assess the vulnerability of the forested areas to the natural disasters such as wildfires, storms by analyzing the canopy height and structure. So in this video I have shown you mapping and analyzing the canopy height using Global CHM dataset in Google Earth Engine, a case study of specific region in Meghalaya, India. So thanks for watching and make sure that you like and subscribe to our channel. So thanks for watching.